a silvery colored metal melts at 1535 degrees Celsius and boils at 2862 degrees Celsius.
Let's go. This is for every child that wants to make it one day. Simple say class and presence of mind is elsewhere. Swing out with Suzanne, Afna already Alispani at the time I is nowhere. I know your pain, you don't have to be scared. The dreams are very pure.
Hi everyone, my name is Sihle Bonani. Welcome back to Basic Chemistry 101. Today we are dealing with matter, the classification of. So today we are trying to classify matter. Now matter you can classify in two principal ways. You can either classify it physically or classify it chemically. So if you try and classify matter physically, you'll talk of physical states of matter, which is your liquid, your solid, or your gas. If you classify it chemically, you talk of your element, compound, or mixture of compounds. Now let's go and classify this thing physically. So your physical classification of matter, let's use the example of water. Now when you talk of physical, you also talk of a physical change. A physical change is a change in the state of matter without changing its chemical identity. So when you talk about water, you can find water as a liquid, but when you can transform water into ice, or you can transform it to a gas. But this is water, this is water, this is water. H2O, H2O, H2O. It doesn't matter the phase or the state of matter, but it is still H2O. So the chemical identity of water hasn't changed, which makes this a physical classification of matter. You classify it by either a liquid, a solid, or a gas. Now, a solid is characterized by rigidity. So a solid has a definite shape, and a solid cannot be influenced by external forces to change its shape. And with liquids and gases, these are fluids. Now, to distinguish between a liquid and a gas, you would talk about compressibility. Now, gases are easily compressible, and liquids are relatively incompressible. Now, you can pump more air into a tire. So a gas does not have a definite volume, no definite volume for a gas, but you cannot pump more water in a container, which makes a liquid to have a definite volume. So when you talk about physical, you must be able to distinguish between a liquid, a solid, and a gas, and what is the difference between the two. What is the characteristic of a solid? What is it about a liquid and a gas? And then from there we can move to chemical. Now, a chemical classification, we will talk about a chemical change. Now, what is a chemical change? It is a change where an atom is transformed to one or more other atoms. So from here, there is a chemical reaction, or there is a change in the chemical identity An example would be when iron mixes with air and water, you would get what is called a rust. Now you cannot iron and rust are two different substances, which means now iron was transformed into a new type of an atom, and that is constituted as a chemical change. Now from a chemical change and physical change, you would have what is called a chemical property. Chemical property is something about iron which involves a chemical reaction. You know definitely that when you mix iron and water and there's oxygen, you are forming rust. So the chemical property for iron is that. And so this one involves a chemical reaction. Then a physical property is something about, or is a characteristic about an element or an atom which does not involve a chemical reaction, or it is this one does there is no change in chemical identity. Physical identity for water is that it boils at 100 degrees Celsius. So we have spoken about a chemical change and a physical change. From your physicals and your chemical changes, you have what is called a substance or a mixture. So this is one other way of classifying matter. Now for you to know that some form of matter is a substance or is a mixture, you have to be able to identify or to differentiate between the two. Now a substance is a combination of atoms that cannot be separated by physical means. And then a mixture can be separated by physical means. Now, if we are talking of a substance and a mixture, let's talk about mixing sodium chloride and water. Now, when these are mixed together, you see a clear liquid solution. Now, but in that solution, H2O does not change its chemical identity, and sodium chloride doesn't change also its chemical identity. Because of that, they can be separated by physical means. You can use a method of distillation. When you distill, water will evaporate at a certain temperature, and then the salt will be left inside your distillation apparatus. Then you have separated by physical means. Now, because this can be separated by physical means, this is a mixture. But H2O on its own, you cannot separate by using those kinds of means. Because you cannot separate it by physical means, this is a substance. And sodium chloride as well, you cannot use physical means to separate it. Now you can call it a substance. For your substances, you have what is called an element or compounds. Now, for elements cannot be decomposed into simpler substances by any chemical reaction. So you can separate H2O to hydrogen and oxygen using a chemical reaction, not physical means. Now, when you have hydrogen and oxygen on their own. You cannot further break them down using any chemical reaction. So hydrogen on its own is an element, and oxygen on its own is an element, because you cannot decompose them into simpler substances by any chemical reaction. And from there, when we talk of mixtures, we can talk of a heterogeneous mixture or a homogeneous mixture. Now, a heterogeneous mixture, you can physically identify the elements or the substances that are mixed together. So it involves physically distinct parts. Let's say if you mix apples and oranges, you can identify this is an apple, this is an orange. When that type of a mixture, you are able to do that. Now you can call that a heterogeneous mixture. But if it forms a solution or a uniform color or a solution, you call that a homogeneous. An example would be this one. You mix water and sodium chloride, you stir, you get one solution, and then that is your homogeneous mixture. Then from your substances, you also get what is called compounds. Now, your compounds are your it's two or more elements chemically combined. And you'd find that your sodium chloride is a compound. Now, from compounds, there were studies that were made, and there's a guy called Louis Sprout. Then he came with a law of definite proportions. Now, a law of definite proportions actually means if you have any mass of sodium chloride, let's say in any mass of sodium chloride, there is about 39.34% of sodium, and there is 60.66% of the chloride ion. So in any mass, whether it's 100 grams or 100 million grams, the mass has to be 39.34% of sodium chloride and 60.66% of chloride. So it's sodium 39.34, chloride 60.66%. That is the law of definite proportions. A pure compound, whatever its source, is always definite or constant, or constant proportions of the elements by mass. So that is what they mean. So we have spoken about the classification of matter in detail. I think for now we have to stop there. But before we stop, let's try and do a bit of an exercise. I'll put it up. It says, decide whether each of the following processes are chemical or physical. So we have to decide. Now we have to keep in mind what we have spoken about a physical or a chemical process. A physical process, there is no change in the chemical identity. A chemical process, there is a change in the chemical identity of that given substance. Now, iron filings are separated from sulfur powder with a magnet. So we're trying to see if there's any change in the chemical identity of iron filings and sulfur when we use a magnet. You find that there is no change in the chemical identity of both those. So for our first question, we would say that is a physical process. Then another question would be sodium. The sodium metal spins vigorously when placed in water, leaving an alkaline solution and producing hydrogen gas. So in the beginning we had sodium metal and water, but in the end we found that we produced hydrogen gas, but we didn't have it when we started. So it means now there is a change in the chemical identity of water, and we also have an alkaline solution, so there is a change in the chemical identity of the sodium metal. So because we have a change in the chemical identity, we'd say that is a chemical process. Now for number 3, ice turns to water when left in a beaker at room temperature. Ice is H2O in a solid phase, and water is H2O in a liquid phase. So the chemical identity is still intact, so this one is physical. And blue copper sulfate turns white when heated. So you have copper sulfate at the start, which is blue, and then when it is heated, it is white copper sulfate. So in the beginning you had blue copper sulfate. Blue copper sulfate is hydrated copper sulfate. So you have copper sulfate and water, and then when you heat, the water evaporates, and then you have water in a gaseous form and copper sulfate in a solid form, which means copper sulfate is still intact. There is no change in chemical identity of copper sulfate. So this one would be physical as well. And then the last one, a dark gray rotten egg smelling compound forms when sulfur powder is heated with iron filings. So a new compound forms. That means there is a change in chemical identity there, which means now when you heat sulfur and iron filings, there is a reaction that occurs to give that smelling compound, which makes it a chemical process. I hope you got the difference between a chemical change and a physical change, or a difference between a substance and a mixture. Because moving forward, we'll have to identify or understand when we talk of one and not the other. And from there, we can be able to move forward. I think we'll make a stop there. And thank you for watching. Please subscribe and leave us a comment wherever platform that you are watching from. But you subscribe so that we grow this thing together. Thank you very much. This is Basic Chemistry 101 with Sihle Bonani. I am Sihle Bonani. Peace. Booyah!